This video is going to talk about how to use the distance formula. This again is one of those formulas that you will see keep coming up in geometry, so it is very useful to memorize. Before I'm going to show you the formula, and then I'm going to kind of talk about how it is derived, because I remember taking my math certification test when I was down in Texas, and I had to use this on a problem and I couldn't remember it, but I remembered how I could kind of figure it out from other things, so I'll talk about that in just a second. So the distance formula looks like this, that the distance between any 2 points, x sub 1 and y sub 1, and then x sub 2, y sub 2. So again, we're looking at points on a coordinate plane. The distance between those 2 points is given by the formula. It is the square root of the difference between the x values squared plus the difference of the y values squared. Okay, again, it doesn't matter which x value you put first, because since we're subtracting, normally it does, but 5 minus 3 is 2, 3 minus 5 is negative 2, but then once we square it, the negative becomes inconsequential. So it does not matter which point you put in first. So you're just finding the difference and then squaring it. So this looks a little complicated, but we're going to look at how it has come about. So if you think about, okay, so here's our coordinate plane. Let's say if I'm looking at these 2 points, so this is at the point 2, 1, 2, 3, 4. This is at the point 3, 4, 5, 6, 4. Okay? If I wanted to find the distance between those two, it ends up being 4. Well, if you look at the points and how you get that, we're really looking at the two x values, because the y values are the same. Okay, so it's just the x values that have changed. So we're looking at the difference between an x value of 2 and an x value of 6. Well, to do that, we took 6 minus 2. Okay, so if you just have points that are 2 points that are horizontal or 2 points that are vertical, then you can just use this. And I think this may have been, I know in the book that I've been looking at, this came like the section before or something. Okay, but you don't necessarily need to remember that formula. But we're going to use this because if we have points, well, I'm going to move that up. Let's say I'm looking at these 2 points, and I want to find the length of that segment, or the distance between those 2 points. Well, now we're at the point 2. Actually, I'm going to move that down so we don't have the double. Okay, so let's look at 1, 2, and let's go 3, 2, 3, 4, 5, 6. So here's, oops. This should be the point 1, 2, 3, 4, 5, 6, 5, right? 1, 2, 3, 4, 5. Okay, so I'm looking at the distance between these 2 points. I can't just count segments because we're not going perfectly diagonal through them. Okay, but if we think about making this into a right triangle, that I can look and say, okay, well, this bottom segment is going to be 1, 2, 3, 4, 5 segments long. The top one is going to be 3 segments long. So then using the Pythagorean theorem, that distance that I'm looking for is going to be found using that. Now, thinking back to, well, how did we get the 5 and the 3? The 5 came from, let me get a different color here. It's the 6 minus the 1 the 3 is the 5 minus the 2. Right, so we're finding the difference between our x values, which is one side of our right triangle. The difference of our y values is the other side of the right triangle. So I'm going to rewrite this over here so you can see it a little better. So we kind of worked backwards a little bit. So that gave us the 5 squared plus the 3 squared equals the d squared. Well, once you work that out to find that d, or if we want to look at this original equation here, if I want to solve this for d, I'm going to take the square root of both sides. So that's where we get that distance formula. Okay? That the two values inside are being subtracted because we're finding the distance between those two x values and the two y values to find the lengths of those sides in the right triangle, and then we square it for the a squared plus b squared, and again it's adding because those are our two legs, those distances are our two legs, and then we square root the whole thing going back to that Pythagorean theorem. Okay, so that may help you to remember that formula. So let's look at a problem. Let's say I have the points -2, 1, and -5, 5. Okay, so I want to find the distance between these. So it's going to be the square root of, I want my two x values, so I'm going to do -2 minus -5, that squared, plus the difference of the y values squared. Okay, so let's see, -2 minus a -5 ends up being 3. That ends up being -4. So we get the square root of, whoops, got ahead of myself there. 9 plus 16, square root of 25, which would give me 5. So the distance between those 2 points is 5. Okay? Now, let's say you are given two different segments. So point A has the coordinates 0, 3. B has the coordinates 5, 1. And let's say X has the coordinates -1, 1. Y has the coordinates -3, -4. Let's do something other than X and Y since we're dealing with points. Let's use E and F. Just kind of avoid some confusion there. So I want to know, is segment AB congruent to segment EF? Well, if those segments would be congruent, then they would have the same length. So I need to find the length of segment AB. So that would be difference of x's squared plus the difference of the y squared. EF would have the length of difference of its x's plus 1 minus -4. I went ahead and changed that since I'm running out of room. Okay, so this would end up being 5 squared. This is 2 squared. So I get 25 plus 4. And I'm just going to leave that as the square root of 29. Okay? Over here, this would be -1 plus 3, so I have 2 squared. 1 plus 4 is the 5 squared, so I can kind of see already. This is going to be 4 plus 25. It's the square root of 29. Since both of those have the same length, that means that they are congruent. So I would say yes, segment AB is congruent to segment EF.